Yes, dear friends, actually we had started in last video the ray optics and I told you many things regarding the reflection of light, regarding the image formation and spherical mirror. I told you definition focus. So I told only but did not write on the board. So focus I told you focus of spherical mirror. Spherical mirrors. I take separately concave mirror. Concave mirror. Rays parallel to ray parallel to principal axis. Principal axis after reflection from concave mirror really converge to a point on principal axis. This point on principal axis is called focus of concave mirror. Dear, this chapter is simple, but you have to learn the basics and you should be able to tell the things. Not only okay, I have got it, but sorry sir, I'm not able to express. No, that does not help. Now if we come to convex mirror, so here you can draw this diagram. मैंने बना था. It is concave mirror, principal axis pole. Here C, so rays parallel to principal axis. I am repeating because this point is important here. So they converge at this point. All the rays coming parallel to principal axis. There is some trouble also, I will tell you later, but basically focus of concave mirror is the point on principal axis here. Rays parallel to principal axis. Ray of light parallel to principal axis after reflection from the mirror converge to a point and up to this point. This is the focus. Now in case of convex mirror, convex mirror, lot of difficulty are faced by students in this chapter, and it is because of so many things. Don't think that you are a fool. No, there are so many things which make it difficult to understand. One, the practice. Second thing, not listening carefully, not listening to the thing, and sometimes we teacher also misguide the students. I should not blame, but this happens. I am sorry to say this thing. So rays parallel to principal axis appear to diverge from focus. I told you. तो पहले आप इसको ऐसे बनाएं. आप पहले मोड़ना इनको. First given dotted line. Dotted means we have produced them back. Basically, the ray have reflected back, and on producing back, they appear to come from focus. So in case of convex mirror, rays of light parallel to principal axis parallel to principal axis reflection from convex mirror appear to diverge from a point lying from point on principal axis. This point on principal axis is called focus. In that last video, actually, I introduced you with this definition of focus, but I did not write like this. I have written here just because this topic is important for the understanding of whole optics. Anna, when I ask, sir, it is a midpoint of pole and center curvature. But this is not definition. Focus means a point where something meet. We have a focus in our body. All the veins are connected to this point in our body. A child in the womb of mother takes food through this. The same way, this focus of spherical mirror is the point where rays parallel to principal axis after reflection really converge or appear to diverge. So this was the point here now. Focal length, you know what is focal length? Distance of focus from pole of mirror. मैं लिखता हूँ फिर बच्चे कह रहे लिखा नहीं आपने. Focal length, distance of focus from pole of mirror is called focal length. It is noted by small f. Capital F we use to mark the focus point. But sometimes people when write to something, they can write capital F also. But generally focal length represented by small f. This is the distance of focus from pole of mirror. Now, why people say that focus is the midpoint of on the principal axis between pole and center of curvature. So here, but that is not definite focus. Focus is the point on principal axis where ray after reflection from convex mirror really converge in case of convex or after diverge from it. Now to prove f is equal to r by 2. Focal length is equal to half of radius. So this question has been asked many times in board exam, and we noticed that students were unable. So first of all, I take here the diagram of concave mirror as well as convex mirror. Principal axis. First of all, you are requested to draw the diagram neatly, and in board exam where you have to draw the diagram, use your pencil, use your compasses, carbon pencil. Don't use pen in drawing the diagram, because if it goes wrong, then you will cut and that make very bad impression. So this is suppose C. Actually, don't draw this by compass. If we have taken this distance C as 20 centimeter, Then exactly at midpoint, 10 centimeter from pole, you mark F. This is F here. The same in convex mirror. It is C pole and midpoint exactly बनाएं तो डायग्राम अपने आप सही बनेगा फिर, ठीक है भाई। तो ये C लिखने यहाँ पूरा तो हमने लिया यहाँ से एक रे पैरेलल, I take this AB ray parallel to principal axis and by definite focus basically this ray will pass through focus like this. AB, mark the arrow certainly. Similarly here, parallel ray AB, after reflection it will appear to diverge from focus. तो इसको पहले मिला लीजिए ऐसे and then produce backward. AB. Let this ray, reflected ray, BF हो गया, BF. और इधर आप D लिख सकते हैं, इसको D find. Now, where is the angle of incidence? Angle of incidence is the angle between incidence ray and normal. In class 10, you are taught a theorem that at every point, suppose a circle here, we draw tangent and radius. तो radius perpendicular tangent, C से जो लाइन पास होती है वो चाहे यहाँ टेंजेंट में कहीं भी है, तो यहाँ पर टेंजेंट तो C, this is normal here, this is normal here, so this is the angle of incidence, this is the angle of reflection. Similarly here, this is C here, join this C here. I could have drawn the diagram first, but I want to show how to draw the diagram. This is angle I here. This is R, angle between incidence ray and reflected ray. So sorry, angle between incidence and normal. है ना? Is the angle of incidence, angle between reflected ray and normal. So every point we join the any point on mirror through C. So here it is normal. यहाँ tangent, यहाँ आएगा तो यहाँ tangent normal. So here it is I. This is parallel to principal axis, and this is here transversal. कौन है transversal? This one transversal. Sorry. This is parallel to this and this, and CBN is transversal. So corresponding are equal. So this is angle I also. Here vertical which angle are equal. So this is R. Here I think this is simple to understand. Are you able to understand? Tell me. I mean, this is angle of reflection. This is angle vertical opposite angle equal to R होगा. Now here how to prove F is equal to R by 2. So you can describe figure. Okay, we take ray AB parallel to principal axis. After reflection, this ray, in case of concave mirror, pass through focus, and in case of convex appear to diverge. In figure, angle I is equal to R होता है ना? Angle in figure 1, figure 2 के बाद में करते हैं बात. In figure 1, angle ABC is equal to angle CBF. बस यहाँ भी है सही ABC, बट यहाँ थोड़ा अलग होगा, यहाँ होगा BCP. तो ऐसे करते हैं. So that is because angle I is equal to R. यहाँ since angle I is equal to R, angle of incidence is equal to angle of reflection. Angle ABC is equal to angle BCP. BCP. Alternate angle are equal. AB parallel since AB parallel to PC and BC is transversal. So which angle are equal? Corresponding angle are equal. Angles are equal. It means hence angle BCP is equal to angle CBF. These angles are equal. In triangle, you know, when sides are equal, angle of union equal, or conversely, and hence side opposite to angle, this is BF, opposite this is FC, and therefore FC is equal to BF. Now here lies the trouble, one thing which creates lot of trouble here. If we assume, assume that B is close to P, then BF equal to PF. Therefore, using this value here, we get, and hence F is equal to PF. And hence PF is equal to half of PC, or PF equal to focal length R by 2. So this way you can prove this here R by 2. So here there is an assumption that B close to P. Actually size of mirror is only size of this one. Distances are large. So we can assume like this point B. Lekin this is not exactly true. दूर होगा तो फिर क्या होगा? Then F will not this point. वो कहीं और मिलेगी. And due to this assumption, actually there is defect in spherical mirror, which is called spherical aberration. बताएंगे बाद में. Spherical aberration एक defect है. Spherical aberration means defect. Aberration means defect. It is due to this assumption. Now in concave mirror, figure 2. In figure 2 I equal to R है, angle I equal to R from large or reflection. ये I equal to R. So what is happening? BF is equal to CF. BF equal to CF. Again, point P close to P. If P is close to P, then BF is equal to PF, and hence PF is equal to FC, and hence PF is half of PC. PC हमारा रेडियस कर्वेचर है ही, ना भाई? And therefore क्या होगा यहाँ? PF equal to half of PC, and PF equal to F. Focal length equal to R by 2. Once this question was asked in board exam, using convex mirror create lot of trouble to students. है ना? तो यूजिंग कॉन्वेक्स मिरर प्रूव दैट F is equal to R by 2. So this simple method, an important thing. You must remember that angle of incidence is equal to the angle between incidence ray and normal. In case of spherical mirror, reflection is there and it has to obey laws of reflection. All things happening according to laws of reflection. Nothing else. कुछ अलग से नहीं है। हाँ भाई, कब सोचो स्फेरिकल मिरर लगे, प्लेन लगे। ठीक है भाई, तो वी कम इन नेक्स्ट वीडियो विद इमेज फॉर्मेशन।